I'm Aggelos Kiayias, Chief Scientist at Input Output and Professor at the University of Edinburgh. In Douglas Adams' classic, The Hitchhiker's Guide to the Galaxy, a Babel fish is a creature that you can use to have any language translated to your own language. Now, in the cryptocurrency space, we have smart contract platforms that make it feasible to anybody create, forge, and use their own token. So this raises the question, is it possible to interact with the platform using your preferred token? This is what is enabled by the concept of Babel Fees, which is the topic of this short whiteboard video. Now, common wisdom in blockchain systems suggests that when you send a transaction to a blockchain system, this must incur a cost to the sender. The argument is that without such constraint, there is nothing to stop anyone from saturating the system with valueless transactions and thus rendering the whole system unusable. So how is it possible to circumvent this seeming impossibility regarding transaction fees and make it feasible for users to post transactions, use their client to post a transaction to a system using as transaction fees any token they prefer? To understand how we can go about thinking about this problem, let's recall how native assets work in Cardano. Tokens can be created according to a minting policy. Here is token X. And such a token can be added to a UTXO. So in Cardano, after the merry hard fork, it will be possible to have token bundles. And a certain UTXO can have different quantities of a variety of different tokens together with ADA. Transaction fees in the ledger are denominated in ADA according to a function which is fixed as a ledger parameter. Now imagine that it is possible to issue a transaction that declares a liability denominated in ADA equal to the amount of fees that the transaction issuer is supposed to pay. So in this particular case, suppose that instead of this particular value here, we declare this as a liability. And let's say this is minus 0.16, an indicative fee that this transaction might cost. Now, a transaction that has such a UTXO is not admissible in the ledger. But we can think of it as an offer that asks for the liability to be covered. Now, why would anyone respond to such an offer? To entice a response, the transaction can offer some amount of tokens, like in this particular case, XY that you see here, as a reward to anyone that wishes to offer and cover the liability. Now this, if you think about it, is a spot trade between ADA for the transaction fee and the offered tokens at a certain specific exchange rate. Now in particular, if you think about implementing this, you can think of a stake pool operator who can collect transactions with such liabilities and match them if the stake pool operator sees that the tokens that are on offer are desired. Now, to see this as a full example, let's consider the following scenario. Imagine that we have Alice, which is a user and has some tokens of a certain type, let's say type X, and let's say there is a certain amount that she possesses on a certain UTXO. Now she wishes to pay Bob an amount of token X, so she's going to build this transaction to consume that UTXO and transfer this to another UTXO, and C would like to give Bob an amount of 9 tokens of type X. Now C would like to pay the fees of this transaction not in ADA but in token X. Now to do that, C will create a liability output that declares the ADA value, and that's minus 0.16, let's say, for the transaction fees that this particular transaction needs to settle in the ledger, and C will offer the token of type X in return. Now observe that this suggests an implied exchange rate of 3-to-1 between token type X and ADA. Now consider a stateful operator, let's say Stacy, who sees that transaction and would like to cover that liability because C would like to collect tokens of type X. Now C would use one of your own UTXOs that has ADA, let's say an amount of 5, and C will create another transaction that would consume the liability and will create a new UTXO that will be controlled by Stacy and will pay the fees for both transactions. So let's say the amount here that remains is 4.68. In this example, let's say we have 0.16 for each of these two transactions, plus claim the 0.48 tokens of type X. Now, if you look at these two transactions together as a group, transaction 1 and transaction 2, they have no UTXOs that have liabilities, and together as a group, they cover all the fees that are necessary, 0.16 and 0.16, a total of 0.32, and in this way, they can settle in the ledger. So this mechanism shows you how is it possible to post a transaction using a particular token that is user-defined to cover transaction fees. Babel fees as a feature is entirely opt-in for Stacy. So if Stacy does not wish to engage in this particular case, C will not issue the transaction that covers the liability. Now, what is interesting about this is that there is not even a need between different stateful operators or other interested parties that would like to cover liabilities to agree on an exchange rate. Every SPO can provide its own exchange rate, and the user issuing a liability transaction can offer an amount of tokens corresponding to the minimum, the average, or even perhaps the maximum of the posted exchange rate in the network. In this way, there will be a natural trade-off between the settlement time of a liability transaction and the market value of the various tokens. So this is how we can accommodate the concept of Babel fees and empower users to price transactions in any token supported natively by the system. I hope you enjoyed this video. Have a great day.